Alright guys, what's going on? So today I'm finally back. Had a little bit of a break there, but I've been working very hard in the background to do some secret projects that I hope you guys will be very excited about. One of which is actually getting all of the parts, or most of the parts. We're getting them little by little for the new F100's engine. So the one thing I want to reiterate here is, like last time when we first built this motor, if you're newer to the channel, about a year ago in November, I took a week from Friday to Friday and took the engine out of my truck, poured it all the way down, had it machined, and put it all the way back together in 1 week from Friday literally to Friday. And I had a totally different engine in my truck, completely rebuilt, all freshly machined, new stuff. But there was a lot of corners cut because of the time constraints that I was at. One of the biggest issues with my existing engine that I have put 6,000 absolutely gruesome miles on, beating the absolute snot out of it, was this thing has a tapered bore. It was an 035 bore. I took it apart expecting a standard bore, and I had a tapered 30 over bore. So I put a 30 over piston with like a 0.35 bore with like a 039 ring gap or something ridiculous like that. So the tolerances always sucked in that motor. So it always piston slapped. But those were all things that I already knew were gonna happen. The other thing is I revved this thing out to almost 7,000 RPMs with no girdle, stock 2-bolt main with stock hardware and stock rods and a stock crank. So that alone on itself was a recipe for disaster. So I knew eventually I was gonna break this thing, but I didn't care. I'm not gonna drive my truck less than what it actually could do or what I wanna do just to make it last a little longer. I wanna please myself, I wanna please you guys, I wanna make entertaining stuff. So with that being said, I'm happy with what it's done. It wasn't even technically supposed to last 1,000 miles when I put that thing together. This was my first engine that I had ever assembled and built and basically put together and designed for myself. So I was really proud of it. So I want you guys to keep that in mind. So this is engine number 2 that I've ever put together. So let's get into what we got going on. We got a couple of new parts I want to share with you guys, and hopefully in this video we'll get at least the crank in it, maybe a couple other things. Like last time, you guys saw the rods, the pistons, whatnot, but our cam is here. So I'll just I won't go too much in depth on it until we actually put it in, but this is our cam specs. Let's see if I can get it to actually focus. There we go, right there. So this thing is a comp solid roller. It's absolutely massive. This thing at around 12:1 with a solid roller, 306 duration at 50 is 271, 104 lobe separation angle, and a 640 lift. I mean, this thing is basically, this camshaft doesn't even really start making power until 4,500, and then it makes power to 7,500. I've seen guys with 12, 13 to 1, 8.2 deck motors rev these things 8,000 plus RPM. I've seen a setup that's 13 to 1 on a 289 base, which is pretty much identical geometry to my long rod 302, just a little smaller, turn 8,400 RPMs with a cam like this. So yeah, pretty nasty. So this thing's gonna be fun. But the other thing is I'm realizing how far this thing's going. I'm not cutting corners like the last engine. Last motor, stock rod, stock piston, stock hardware, like I said, hypertonic piston, you know, pretty bare bones, a camshaft that I had, a lot more budget friendly. I probably had about $3 grand in the whole rebuild, done and done, machine work and all. And there was a lot of changing things in between that had to be done. So that was a cheap engine for me to put together. Obviously it could have been done a lot cheaper, but given my time constraints, we had to make a lot of things happen. So this one is well over 10 grand. Big difference in numbers, and I'm not cutting any corners. So if you guys have been following along with my social media lately, if you follow my Instagram, I posted a lot there at the Craig909. We're actually the same show that we painted Sean's Super Cab for last year. It's at the Westworld of Scottsdale. It's the Good Guys custom rod show out there in Scottsdale, Arizona. And it's actually the largest like grouping of crew cab Fords like on the West Coast that I've seen. Bunch of our friends that, you know, I've showed on the channel before, all of them are bringing basically their best crew cabs out. I figured what better way to debut this whole engine setup and get my truck back together than to bring it there and have it out at that show. So one way or another, the truck is going to that show. I just don't know if it's going to be with this new engine or we're going to repair the engine that's in it. Because keep in mind, my truck still runs. But given the value and pricing of everything, I mean, just the cam setup alone, the lifters for this engine, the lifters are $700. Not sponsored. $700 for lifters. God, why? So I'm not cutting any corners with this engine, and so if it means a time constraint to where I have to rush things, it's not happening, and we're going to fix the engine that's in it. So if it comes down to it and we have to repair the engine that's in my truck, this is a standard 68 date coated crank. It's not even 10 under, it's just been polished, it's ready to go. So in theory, if I wiped out a bearing and messed up a journal in the crank, or I messed up a rod, there's stock rods in that motor, I can get another rod and then we're good to go. So I can make sure that this motor is repaired. I can repair it in like a day or two. It would not be that hard. So if it comes down to it and we're like a week before the show and we're not even close with this new engine, we'll just fix the one that's in it and we'll call it a day. But anyways, sorry for the talking. I just really want to set the stage of what we're actually trying to do here and make sure it's not something I like bury my myself in a hole trying to get out of. So I want to take my time with this engine. I really, really, really need it to work. If this engine breaks, I'm gonna go bankrupt, I swear. So it just needs to work. I want to take my time, you know? So good things take time. But today we're gonna go ahead and we're gonna roll this thing out and go ahead and wipe it down, make sure everything's all clean. We're gonna get the crank in it, which is not that crank. It's that one that's on the floor over there. We're gonna set our crank in it and maybe get some rods out and start putting stuff together. So yeah. Alrighty. You're gonna make some horsepower. You're not gonna break, alright? Cool. Glad we're on the same page. So, didn't reiterate this last time. 68 day coated block, 30 over, new cam bearings, new freeze plugs. I think it's just a 10,000ths off the deck. But yeah, pretty straightforward. Nothing too crazy about it. It's a C8 block. Yeah, so this thing's been sitting. I've had it for probably about 2 weeks. It's been kind of sitting in the garage, so naturally working in the garage dust can still get in it. So I'm just gonna make sure I wipe and clean the whole thing pretty good before I go too far. You don't want, in case there's like a metal shaving or something in there. Alright, so I got my Cleveite bearings. These are the main cap bearings. Same exact bearing I used last time. They work fine, given the circumstances. Since I'm gonna have a girdle in this thing, the crank shouldn't walk at higher RPM, so these will hopefully last a lot longer. So I'm gonna put these in. You're supposed to put them in dry. I'm gonna open this, lay them all out on a clean towel. The biggest thing I've learned. This is our bottom one. So this is pretty self-explanatory. It's just everything goes in with the little tang thing tabbed down. The feeler gauge and make sure they're actually perfectly flat. And I'm going to try to avoid using a rubber mallet on anything. I want to just do it by hand. I don't want to force anything. It doesn't need to be forced. So I'm going to get all these bearings put in and we should be good to go. So check this out. So this is our rear main cap. Regular main cap, nothing too special about it. And it actually has this rope seal. These are actually from the factory, had like a rope seal style. And it was centered by this like rubber locating dowel pin that kind of like went in. It was part of the seal. You can actually see the little hole right there. It kind of sat in. And if you don't pull these out and you use a new seal, it leaks. So I don't really actually remember if on the last motor I took this thing out. So I need to go ahead and pull that seal out so when I put my new 2-piece remain in it doesn't leak. And we don't have any sort of leakage because my last motor leaked a bunch, mostly because of crankcase pressure, but I think this might have had something to do with it also. So to make sure that guy seals perfectly, we're going to go ahead and pull that guy out. Got it. Aha. So that little guy, if you don't take it out, you put the rubber seal in, the rubber seal doesn't have a hole, and it'll push the rear main out and you'll have a big oil leak. So now that guy's out, should be good to go. Okay, so it's the next day because I suck and I forget things. So I had to get a rear main. I had a bunch of 1-piece rear mains, but for some dumb reason I didn't have any 2-piece rear mains. So now I have one, so now I can actually put the crank in it. Have some assembly lube and some canned Cheese Whiz stuff. If you haven't used this, this is like the greatest thing ever to put any sort of engine parts together with, because you're not trying to squeeze the tube and get it all over yourself and it's just a mess. So this stuff's awesome. So yeah, I'm gonna go ahead and throw the bearings already in it. Took them back out. What didn't happen is a little plug that goes in the back of the cam journal on the block was not installed, so I had to bring it down to the machine shop, get one of those put in. So I did that this morning. That's another reason it's the next day. But yeah, I'm gonna go ahead and throw everything back together the way it was, get the crank in it, get it all torqued down, and hopefully we'll have a crank. So yeah. Alright, so what I did, ignore the stud placement. I'm just checking tolerances. Unlike my last engine where I just threw it together, hoped everything was fine. It was for 6,000 miles. This one I actually want to check everything. So I just torqued everything 65 foot-pounds on the mains, and pretty much right now, you can see this is just me with my hand, and there's no crank bolt, there's no wrenches on this thing. Left hand, not even my dominant hand, and I can turn this thing pretty freely, which is good. I can hear the assembly lube kind of moving around. It doesn't have any tight spots, which is good, and it seems to do a full 360, which is what I want. That's what I'm checking right now. I want to make sure it does a full 360. So what I'm going to do now is I have a magnetic base dial indicator. I'm going to place on the base and grab the front of the crank. I'm going to take a dead blow hammer and basically go forward and backwards and check my end play. I didn't do that on the last engine. I have no clue what it was. Probably wasn't that great, to be honest. So this one I want to make sure it is good. So I'm going to go ahead and check it on the thrust bearing, and that'll basically tell us if we need to take some material off of that bearing. I have a good feeling it's probably good. If anything, it might be a little too tight, so I'm going to check that. All right, so I've got a dial indicator right on the snout of the crank. I'm going to go just grab like a pry bar or some sort of something to move the crank back and forth with. I'll just use a smaller one with a rag around it. I don't really want to put metal on metal or anything. I don't have to. So I'll just take the end of a pry bar and wrap it in a rag. And I'll basically... I already knew mine was tight, so I don't know if you guys can see the gauge, but it's like... So that's only 2 thousandths. Moving the crank forward. If I move the crank backwards. So it looks like we have 2 thousandths one way or the other, which is a good thing. I got my little cheat sheet book. So 4 thousandths to 8 thousandths is good. I think there was maybe 5 thousandths, maybe 3 one way, 2 to the other, it looked like. Yeah, so it's about 5 thousandths is what this crank's at, so I'll call that good enough. I'd rather have it a little bit tighter than looser, because as this thing warms up, it'll expand out. I'd rather it not be like 10 thousandths or something crazy to where the bearing's super loose in there, so that seems like something I can live with. Still seems like it spins perfectly, and I think we're pretty much ready now to go ahead and pull everything back apart, unfortunately. And I'll go ahead and I'll Loctite up these studs because I want these to stay in, and then we'll go ahead and we'll retorque this thing down for the final time, and our crank will be set in this motor. Done. Alright guys, so I got this thing pretty much all the way together. Everything spins, rotates nice and freely, easily, feels good. Our crank end play is looking at about 5 thousandths, which is exactly where I want it, 5-6 thousandths. Looks pretty good. So from now, this is basically as far as I'm going to put this thing together tonight and in this video, and here's why. So what we're going to end up doing now is actually pulling this thing back apart, and you're probably wondering why. All of you guys have probably heard of the mystical like 500 horsepower and then you break a small block in half. These 8.2-deck motors at 500 horsepower, that's like the magical number that a lot of people like to think that these things just magically break or crack or split in 2 pieces. Or that's like the danger zone, I guess you could call it. But really it has nothing to do with that necessarily. It's more so the harmonics that play the biggest role, not necessarily a horsepower or stress. It's the stress combined with a harmonic at that RPM, because you don't break a 500 horsepower motor at 300 RPMs. That does not happen unless you have a ton of boost. But motors do break under insane amount of harmonic vibrations. Now, if you remember with this engine, this is internally balanced. This is pretty much a lightweight rotating assembly. Everything is fully balanced. I had this crank rebalanced twice. So you can see this thing has actually been rebalanced again. So this thing should be perfect. But the one thing that you might notice on a lot of these blocks is they have this casting flash that kind of protrudes outward. It's kind of ugly to look at. It's sharp. It kind of cuts your fingers on stuff. And the main issue with it, basically looking throughout the entire inside edges of this motor, it creates a shear point and a strain point on this engine that actually can develop cracks. So what we don't want is this thing to break, obviously. And we're going to be spinning, 7,000 plus RPM. We don't want to create a shear or stress point anywhere on this thing. So when we look at the edge of this block, so we have a horizontal and a vertical plane coming together at a point, which is the edge of the block, right? So what can actually happen a lot of times, and it happens a lot on the oil galley side for the same reason, is what will happen is basically the harmonics from the center of the crankshaft at a specific RPM will basically go outward, and then it will hit the same plane, structural plane on the vertical direction on the block, and it can actually create, like, let's say a crack that will go down the side of the block this direction downward off of this corner, downward off of this. So basically if you round this off just a little bit, you're getting rid of that sharp edge where the 2 planes come together, and it's more of a gradual transition. Now that will relieve the stress because it's not as much of a finite point. So I'm going to go ahead and actually bevel this off. Nothing too crazy. I don't want to like say I'm going to put a 45 in this and take a flat disc and shave the whole thing. Just gonna take a light little sander, maybe a carbide bit, just take some of this flash off, because this is all stuff that doesn't need to be there. Plus it looks bad. I mean, you can really say it saves weight. It's really unnoticeable. But mostly just stuff that's coming close to the crankshaft. I want to make sure that that stuff is all ground out, and it's all, you know, stuff like this that looks not really that great. You know, these are all spots that are not consistent whatsoever. So these inconsistent points, you know, specific RPM harmonics can actually create cracks in this part of the block. So I just want to prevent that. It's not going to hurt anything to do it. And with the way that we're going to drive this thing, I want to make sure this thing will actually handle what I throw at it, because you guys have seen how I drive this thing. So with that being said, I'm going to go and pull this thing apart and start grinding it all out. Alright guys, so our block's pretty much ready to go. I kind of deburred everything that I thought needed to be deburred. I didn't go too crazy, but enough to where it makes me feel a little bit better about what I did. So looking at this, basically, like I said, just all this casting flash that's inside of here. I didn't go up into the journals, obviously. You don't want to mess with that. So you just go right up to it. Then kind of around the surface here, inside of here, we kind of deburred and beveled all these edges. Nothing too crazy. I wasn't talking about leather shaving, I was just deburring it. So all the way around, these edges are all nice and deburred up to where the main caps go. Did not touch that. Don't want to touch that. That needs to be a machine finish. Otherwise you'll have leaks, problems, and all sorts of other stuff. Then coming down and around here, this is really common. Outside on the corners of the outside of the block are usually pretty covered in excess material. We shaved a lot of that off. You can see there's some right here that we deburred, as well as in here, coming around the front. I just went ahead and just shaved all these edges. Just made everything nice and smooth. Nothing too crazy. All this flash got ground off, and even around here is all, this was really bad. So right around here is all completely taken down, which looks a heck of a lot better because I flipped this thing over. Okay, so on the top, what I did here was basically shaved all my oil passages. So right here in this front one, typically is absolutely full of excess material to the point where oil doesn't flow through this as adequately as you would want to. So what I did is I kind of opened that up a little bit, deburred it. There was a ton of material in here that didn't need to be, so now the oil can flow back down into the pan and over the front of the timing chain the way that it should. And then along this, I basically just kind of chamfered all these edges around on these oil drains just to make the oil flow into it a little bit more. Now I've seen guys fully shave all of the casting material off of the top of the block and then coat it so it's nice and slick and whatnot. I don't really care that much. This is just enough to make me feel a little bit better, like I said. So as you can see, this thing looks pretty good. It's pretty much covered in metal shavings, so now I gotta throw some Dawn dish soap or any sort of soap with a detergent on it, and then blast this thing off with some water. So we're gonna go ahead and give this thing a deep clean, and then we'll be ready to assemble it. All right, so I figured I'd show a couple of other things that we got. So basically the entire oiling system of this thing is all Canton stuff. So Canton studs for the oil pan, because I managed to break a bunch of bolts on the other motor and that bugged me. It came with bolts because I have a girdle. I really want to use studs, so we'll get to that in a second. But it came with its own ARP studs that are basically sized for the windage tray and the girdle. This is the windage tray. So this thing looks pretty good. Let me go grab its own specific gasket, which is pretty nice. So I don't have to just hope one fits. Then we have the actual girdle. So this is probably the biggest, most important piece of this whole thing. What I didn't do on the previous engine, because I didn't know too much about them, and then I realized this is probably what would have saved the engine that's in my truck if I had one of these. So what this does, basically, it's a girdle. It holds all of the main caps in line. So basically, in between on throttle and off throttle, the crank can walk a little bit, or even at super or high RPMs, the crank can walk a little bit. This prevents so the studs and crank from wanting to move around a little bit. So it makes the thrust bearing last longer, makes all the bearings last a little longer, and it basically strengthens the entire bottom of the block. So a lot of the times when you run studs, you're basically slipping this thing over and bolting it down, and it basically secures the entire bottom half of the motor together. This is all hardened steel. It's pretty dang heavy. The issue that I'm currently having is the studs that I have are set up for a windage tray, but they're not set up for a girdle and a windage tray. So you look, this thing's like ½ an inch thick. It's very thick. That's why it's so heavy. So this thing needs to be studded, in my opinion. I could run these. These come with it. If I wasn't trying to turn, 7,500 plus RPM, wouldn't care. I would run these, but I think being that we're going to push such a high RPM, I think I'm going to hold off on actually putting it all in until I get the correct studs. So I'll save the studs that I have for the motor that's in my truck, and I think I'll just order the right studs or see if I can try to find them. So luckily, I just can measure these bolts and I'll know which side studs to get. So that's good. But yeah, so I'm going to go ahead and wash this block off. And then I have this, it's like a 7-quart, 9-inch deep rear sump pan. I used to have a front sump, and then I dumped oil like pretty much all over the cross member. So we have a Canton pan too, as well as an oil pump. So everything's pretty baller on this setup, not gonna lie. Alright guys, our block's looking pretty dang good. It's all cleaned up, washed up. It's kind of sitting out in the sun a little bit. Well, whatever sun I've got left. So you can see actually what I did here inside the oil galley. It's all looking the way it should. No more burrs on anything. Any sharp edges have been just kind of rounded off just enough to where they're not sharp. You're not going to cut your hands on anything. You can see over here, this is all deburred over there, as well as on the bottom all the way across this thing. It looks really good, so I'm very happy with it. It'll serve its purpose, which is good. So I'm actually gonna wrap this video up right here. So it's a little bit of a shorter video than I wanted, but nevertheless, I wanna make sure I get uploads for you guys. Been behind, which is a little bit of an understatement. So I wanna make sure that you guys have stuff to watch. I'm gonna go ahead and pick this video back up. We're actually gonna go ahead and get, hopefully, the short block actually put together in this video now. I think I have everything. I gotta go get a timing chain and some hardware. And in the following video, expect the crank, pistons, and rods all in this engine. So it'll be a fun video. I'll catch you guys then. Like the video if you did enjoy it. Let me do think down in the comments below. Once again, I'll catch you guys in the next video. Bye guys.